All right, as promised, we're going to start to take a look at the uncertainty. This is actually the path that I chose to you is going to we are going to do a backward pathway. So I'm going to tell you first the functions, and later on I'm going to explain to you how to generate uncertainty. But the functions of uncertainty later on at the end, every researchers has to put the uncertainty in the data processing like this. So the form of uncertainty is plus minus, meaning the value of each of the data can be plus or minus of certain other value. Take a look at the A in here. This graph, this bar graph, is actually the relation between glycerin addition to the water content of paper soap. The A will be zero glycerin added, the B will be 10%, and so on and so on. Let's see the A. When there is no glycerin added, the blue one is the soap that is coming, or sorry, the soap that is produced by using coconut oil. So and then the red is VCO, from VCO, virgin coconut oil. Um, uh, Both of them are soap, but the substance is different. So take a look at the blue one first, A blue one. So the value of water content in there is 22.01. Okay, and then it's plus minus 6.02. So it gonna be ranging from the 22.01 plus a 602. Let me get my calculator. Um, I'm sure by now you already have the answer. And 01 plus 6.07, it's gonna be 28.08. This is plus 6.07, and then 22.01, 22.01 minus 6.07, 15.94. It means we don't have the exact value. I mean, we don't have the true actual value. What we will have using the measurement is always a range of the value. It will never be a true actual value, single value. Why? Later we will talk about that. I'm just going to tell you this, that the meaning of this 22.01 plus minus 6.07 means that the value of water content are ranging from 22.07 plus 6.07, 28.06, or and 22.06 minus 6.07. So there's going to be 15.98. Okay, so that's why later on there is this error bar. So if you take a look at the data in here, the trend, it seems, for let's concentrate with the blue one, yeah. The trend kind of, maybe it's decreasing. Okay, let's see whether this is true or not, because this is ranging. Also, this is 28. The max value, the minimum value is 15.64. Okay, the 16.64 is around here probably. I hope you can see that. Let's see the lowest data in here. In lowest data uh, you have 13.38 plus minus 3 point, what was it, 3.33. So the range will be, let's see, 3 13.38 plus 3.33. It's gonna be 16.71, and then 13.38 minus 3.33. It's gonna be 10.05. So if you plot 16.17, it's probably in here. So you go here is the maximum and the minimum is 10. So probably, um, yeah, there. Okay. So if you take a look at this one, well, you cannot say, well, first of all, the lowest value in the highest in here in A is 60.94 here. But at the end, there is still possibility that the value is 16.71. Do you get it? So it's overlapping. So if you go here, it's overlap with the value of this. So it's gonna be it can be a straight line graph because it's overlapping. So because of this, we cannot conclude that there is in decreasing trend because using the uncertainty of the measurement, using the error of the measurement, the range of the value actually the highest value. Let me give you better picture in here. So let's say this is 5, this is uh, 5, and then 10, and then 15. Yeah, let me give, and then let's see again, and then 20, and then 25, and then 30, something like that. Yeah. Now, the first value is 22. 22 is around here, for example. 22 is around here, but the error bar can be until 28, meaning here. And then the lowest part will be 15.9, probably here. But the lowest point, let's say the lowest point is 13.38. Yeah. So 13 probably maybe here. Uh, 13. Okay. If you just take a look at uh, this value and this value, yes, it looks decreasing, yeah, it looks decreasing. But then this 13.38 can also be 16.71, remember? So 16 is probably, mm, 16 is probably around here. So this is the value, and then 10 is probably around here. So as you can see in here, the value can be this, right? And this is the lowest from the first data. As you can see, this is even increased, it's not decreasing. So that's what we call it overlapping. So this is the overlapping, showing that the data is not actually decreased. It's in the range of overlap because the last data can be 16.71. The first data can be 15 point something. It even increased. Well, yeah, we cannot conclude because 16.71 probably can be also here 15 point something, as long as this is ranging from 30, 10 until 30. So the range is this. So the value can be anything in this range. So this is not decreasing according to the error bar. So how then the decreasing look like? Well, the decreasing look like probably, oh, let's see if this is 20, for example, and then this is going to be the error bar. Maybe this is 25, and then let's say in here is 15, in here is 20, okay. And then the last data is, let's say, need to be like super low in here, and then here, and then here probably this is, I don't know, 5, and probably this is 10. So in here you can see this is 5, this is 10, this is 10, 0. The lowest and the highest, see, there is no overlapping. Now with the highest in here is not overlapping. So even when you assume this is the lowest part, and even when you assume the last part is the highest part, there is still space for them to conclude as a decrease. That's why there is decreasing in there. Wow, hopefully you understand. So the error bar later on is used to know the overlapping between the lowest and the highest data. So when you have the data later on, what you need to do is you basically have to remember in your data there must be two value that you have to find. You have to pay attention closer. The first one is the highest data, and then the second one is the lowest data. Okay. Um, Usually this is the first and the last data, or the last and the first data. So end to end data. So this is other one end. Ini, for example, another end. Okay. So um, if in this example, the last data is actually not the data. This is standard national Indonesia for the water content, but the investigation itself is stopped in here. So take a look at two data, the highest data and the lowest data, and then you are going to minus the minus minus the highest data with the uncertainty, and then plus the lowest data with the uncertainty, its own uncertainty. If you find overlap, uh, meaning this is supposed to be higher, yeah. For example, if the result in here is A, okay, so highest minus uncertainty, and this is the highest is this B. If, for example, B less than A, if B less than A, then yeah, there is decreasing in there. There's decreasing in there. But basically, you have to find out whether A or B is overlapping or not. The meaning of overlapping is what I said before. Okay? Yeah, hopefully you understand. Thank you. We will repeat it again later.